A quality installation of a Monitor Pitless booster station can be made easily and economically without the delay for masonry or building construction, creating a sound cost-saving solution. The first step is excavation of the site where the Pitless booster unit or units will be installed. Follow all local and national safety codes pertaining to trenching and excavation and obtain required permits. Contact the appropriate agency to have underground utilities marked before digging. Make sure that the hole is deep enough to have the suction and discharge piping below the frost line and still allow for the proper casing extension above ground. Be sure to create a solid base with roughly 12 inches of self-compacting stone. In addition to providing excellent base support, backfilling with self-compacting stone allows for easy removal should the Pitless booster unit need to be pulled out or moved. The Monitor boosters can now be installed. Leave the cap attached to the Pitless booster units to prevent backfill from entering the upper casing. Utilizing safe and secure means, strap or chain the upper casing under the weld caps. Set the Monitor Pitless booster units in the excavated area. Make sure the canisters are plumb and spaced properly. Typical spacing is 36 inches on center for 2-inch to 6-inch water lines. Spacing increases to 48 inches for 8-inch to 12-inch water lines. Spacing may be modified to meet site dimensions. Backfill to the bottom of the discharge body or below the 1-inch weld coupling. The weld coupling is supplied with a square head pipe plug. The 1-inch weld coupling will provide an air release for the tank on 5- and 6-inch Pitless booster units. Once the partial backfill is completed, use a level to ensure boosters are still plumb and square and have not shifted during the procedure. Connect gate valves to inlet and discharge of the Pitless booster units. This will allow the Monitor Pitless booster units to be isolated for maintenance or repairs. Next, lay out and connect inlet and discharge piping to the gate valves mounted on the Pitless booster units. Now, install the air release line from the 1-inch weld coupling located at the top of the tank on the Pitless booster unit. Excavate site to set the concrete vault. The vault typically houses the pressure transducers, air release system, flow meter, control valve, and sump pump if required. Baker recommends installing a pressure gauge to confirm the pressure transducer is properly scaled. This station incorporates a flow meter along with suction and discharge pressure transducers with pressure gauges. Next, install a blow-off valve on inlet of the station. The blow-off valve will eliminate pressure within the tank when servicing the pump and for debris to pass during a line break. An additional blow-off valve can be installed on the discharge side to create artificial demand when commissioning the pump station. Next, run electrical conduit from the Monitor booster units and transducer vault to the pump station control panel. Use suitably sized conduit according to local and national electric code authorities for the size of wire and conduit to be connected to the pumps. Here, the contractor elected to mount the control panel enclosure on the concrete vault, allowing the electrical conduit to mount to the side of the enclosure. Typically, the enclosure is mounted on a separate concrete slab, using a ground mount enclosure or stand kit. In either type of enclosure, the conduit would need to be stubbed up in the area where the concrete will be poured. After the concrete cures, the enclosure may be installed. You can now connect the inlet and discharge piping to the water main. After the piping is in place and secure to the water main, pressure test the system to ensure no leaks exist. Prior to final backfill, set all the valve boxes and complete the air release system. At the end of the air line, install a lead-free brass ball valve, followed by an air release valve. Typically, the air release system is housed inside the concrete vault with the pressure transducers and pressure gauges. This station houses the air release system in a small vault located between the two pitless booster units. The air line must be housed to prevent freezing. Size 8-inch and larger pitless booster units house the air release on the top flange of the spool within the upper casing, eliminating the air line to the vault. Backfill above all piping must be made with dirt to prevent freezing. Do not backfill with rock or gravel. Once complete, backfill the remaining area, typically 12 inches below the top of the upper casing. Refer to local codes to ensure proper extension of the casing remains after backfill is complete. Once the insulating barrier is completed, you may complete the final cover with stone to reduce site maintenance. After final backfill is complete, the spool assembly can be removed. Be sure both inlet and discharge gate valves are closed, isolating the booster unit when removing the spool assembly. Remove the booster cap and slowly loosen hold-down assembly nuts. And take note that the assembly remains seated. If the spool assembly rises as the nuts are loosened, the inlet gate valves may not be fully closed, or a significant amount of air is trapped underneath the spool within the tank reservoir. Connect a strap or hook to lift the bail. The hold-down hooks must be free from the casing before applying a small amount of vertical force to the lift-out bail. The spool will unseat within the discharge body and continue vertically towards ground level. This station has elected to mount the control box on the concrete vault. The electrical conduit connects on the side of the enclosure. Run electrical wires from the pump station control panel to the monitor booster. Be sure to allow for additional wire to reach the submersible motor leads below the spool. With the spool removed, it is now very important to flush the Monitor Pitless booster units with system water prior to pump installation. Be sure to plug the electrical conduit to prevent water entry during flushing. If the electrical wires are present, take measure to prevent wires from getting wet. Slowly open the inlet gate valve to purge the pitless booster unit and associated piping of any dirt or debris from the line. The water will run out of the top of the pitless booster unit, taking with it debris. Once the water is clear, flushing is complete. Slowly close the inlet gate valve. Follow the same steps for each pitless booster unit. Use a bailer to remove excess water. The water should be 1 to 2 feet below the discharge body before setting the spool assembly. This will prevent water from accumulating above the spool when seated. With the spool assembly removed, the next step is to attach the drop pipe, check valve, submersible pump, and submersible motor to the spool assembly. This can be done vertically or horizontally. The size and weight of the pump and motor typically determine the installation method. Refer to manufacturer installation instructions for a complete guide. Remove factory-supplied drop pipe and apply a generous layer of joint compound to the threads. The drop pipe is not secured to the spool assembly from the factory. Cover all threaded connections with a generous layer of pipe joint compound to ensure a watertight seal. Use a wrench to securely fasten all connections. Attach the check valve to the bottom of the drop pipe. Attach a pipe nipple to the bottom of the check valve. The submersible pump can now be attached to the spool assembly. To prevent cross-threading, spin the submersible pump counterclockwise until the threads seat. Then tighten. Once secured to the spool assembly, the submersible motor can be installed. Before installing the submersible motor, inspect the motor for any damage, including motor leads. Submersible motors are normally water-filled. Be sure the motor is filled before operation. Complete a megometer test, commonly known as a Megger test, on all motor leads before installation. Refer to the manufacturer for proper readings and instructions. Always handle motor leads with care at all times to avoid damage. If readings are acceptable, attach the submersible motor to the pump. Be sure to rotate motor shaft to align with coupling splines. Once aligned, evenly torque bolts in a crisscrossing pattern and secure in place. Electrical splices can now be completed on the spool assembly. by a licensed electrician following all applicable NEC codes. For detailed splicing techniques, refer to the manual of the motor manufacturer. This station used blind butt connectors to make the splice, crimping the conductor into each end before covering with heat shrink. After heat shrink is complete, Baker recommends taping over the heat shrink for additional protection. Once the splices are complete, attach the cable guard to the submersible pump to protect the motor leads. Pull the additional wire through the spool and secure the wire to the check valve or drop pipe. The top flange of the spool will have 4 compression fittings, or cable glands, sized appropriately to seal on the outside diameter of the wire. The electrical wire must be round for proper seal. Ensure the threads on all fittings have been secured with joint compound to prevent any leaks. Tighten the cable glands on the outside diameter of the wire's insulation to create a compression seal. The compression seal is rated for 150 psi. The inlet pressure cannot exceed 150 psi. The cable glands are not exposed to the submersible pump's discharge pressure. Leave an adequate amount of extra wire in the upper casing to accommodate future splices for repair or maintenance. This will also allow the pump and bail to be pulled out without disconnecting the electrical splices. If an air release line was not installed on the tank exterior, install a low-lead brass ball valve on the top flange of the spool, followed by an air release valve. This will eliminate any accumulation of air within the tank. Apply a generous layer of petroleum jelly to both O-rings. O-ring protectors are specifically designed to prevent damage to the O-rings during pulling or setting of the spool assembly. The spool assembly is now ready to be set. A crane will be necessary to complete this task. Be sure to guide the spool assembly until both O-rings have cleared the casing. Then, guide the electrical cables to prevent damage. Once the spool is seated, place hold-down hooks into weld caps and tighten. Now, slowly open inlet gate valve. The system water will push all air out of the tank. The air release will seal and become quiet when all air is eliminated from the tank. Complete the splice between the control panel and pitless booster unit. Be sure to leave additional electrical wire for future splices. Carefully place additional electrical wire inside the upper casing. You may now place the cap on the upper casing. To confirm continuity of all splices, complete a megometer test on the submersible motor leads at the control panel. The submersible motor needs to be fully submerged in water, in particular the splice, to properly confirm the splices were done correctly. Refer to the motor manufacturer for proper readings and further instructions. If the Megger test is acceptable, connect the leads to the output of the VFD located inside the control panel. You may now finish the installation of the Monitor Pitless booster station by securing the cap to the upper casing. Installation is complete. For reliability, superior construction, and overall maintenance-free use, trust Baker Water Systems for all your high-capacity water system needs. For more information on this and other products, visit our website at www.bakermonitor.com or bwsmobile.com.